In this video, I'd like to go through making a compressor in SolveSpace, and I've made a comparable compressor in FreeCAD, and I'd like to do both of those in this video because a lot of my viewership is in FreeCAD, and this is probably a good opportunity to compare the user interface, the workflow, and everything else. Both platforms, I think, are totally brilliant in their own right. Why don't we get started by making a new part? And I'll make a line over here. And just like in FreeCAD, you can see when I get to the right orientation, the auto constraint shows up, and I can use the escape key to stop drawing the line. Come up here, and just to make sure I did draw a little micro line there, so we'll quit that. I guess just one more line. There's the horizontal constraint. W will make your view normal to the work plane again. So I highlight this line and choose dimension. And we'll add in 152.4. There's a full set of hotkeys for vertical and horizontal like I use in FreeCAD. I'm not using them in this video for SolveSpace because it is so different than some of the other platforms, and I've already learned the hotkeys for FreeCAD and Onshape and XDesign and SolidWorks that I feel like if I add another platform that I regularly use hotkeys for in the same sketching environments, that I'm just going to overload myself. So I'm kind of avoiding that right now. So let's grab this and let's go with coincident, vertical. Just adding these with the GUI here. We'll give this a dimension of 1.59. And then we'll give this a dimension, let's go with negative 6.35. I want that to be negative. I guess this doesn't do negatives like FreeCAD, so that's another good comparison that we got right there. 6.35, there we go. And when you are fully constrained, your degrees of freedom for this sketch, right, this is the sketch we're doing, is going to say okay. We can also go into the details of the sketch and add a few elements if we want to, but and it will also look at specific things in this group that it will point out, and you have your degrees of freedom listed over here, right? So we have 1 degree of freedom. I'm thinking it is right here, or rather right here. Let's give a dimension there, and we should be fully constrained. Let's go with 2 millimeters, right? So we go home, everything is good. So now that we're fully constrained, oh, and I put this right on the origin. I did not want to do that. So this will be a good actually case that I didn't mean to do, but we will, of how do we undo some of our degrees of freedom. So let's go to constraints. Here we have a coincident constraint, right? And that's right what we need. And that's pretty easy. I simply go to constraints and I hover my mouse over, and I can see that I've got a coincident on my origin. So unselect all here and find the right one. There it is. From here, I'm in this coincident constraint, and I just hit the delete key. Bam. And that should give me my degree of freedom. And my 6.35 has gone to the wrong side again, so let's add that in the orientation that we want to. 6.35. I can add in a horizontal constraint. I actually want to give this a distance. We'll give that a distance of 25.4, and we should have 0 degrees of freedom. And now I'm in the right spot, right? So let's go through how to revolve in SolveSpace. I think this will be the first revolution that I do. First, we want to define the axis that we revolve in, and SolveSpace has kind of a creative way of doing that. You select what's called a normal, and this is an arrow, and I I presume you can do a line instead of a normal as well if you want to sketch out a line. And that defines the orientation, and orientation only. So by selecting this normal, I'm saying I want to go with a vertically oriented axis, right? And I'm not saying where the axis is, I'm just saying I want the axis to be parallel to this normal. And then you choose a point, and your point defines where the axis is. So in this case, the axis is placed on the origin, and in the vertical, you'd say, this green axis is orientation here. With those two selected, I can now revolve, and I simply click on this button, and we're given a revolve of our sketch. Really handy, pretty simple. Let me break that down a little bit more, though, if you have any further questions. So in the history tree, you can see our revolve, or what they call lathe, is added to the tree, and I can roll this back to view my sketch, and I can roll it back forward again. So we are fully parametric here, and I think it's a rather convenient way of doing it. Let's hit the delete key, or actually, you go into the lathe, right? So I click on lathe, and I hit delete, and that rolls me backwards. Now, if I say I want to revolve around this point at this orientation, and you can tell that we are going to revolve now around this axis that you can visualize because I specified this location with this orientation. So if I revolve, you can see we've revolved, off center around that axis. Similarly, hopefully this may clear up any questions that anybody might have. I can revolve this orientation on this point, and we would be revolving off of this invisible line that I just moved my mouse down. When we revolve, and you can tell there it's an infinitely thin revolution that isn't valid. If we go home, you can see we've just created an erroneous surface. It's not good. So we're going to delete that. And let's go back to the revolve that we originally had. Hopefully that shows you how to revolve in SolveSpace, because I haven't covered that on this channel yet. Right-click pans, center mouse button will adjust your view. And then, of course, scrolling is your zoom. So now that we are here, we'll come back home. Let's do the same thing in FreeCAD. And I'll go a little bit faster because I've done a lot of FreeCAD on this channel. We'll create a new part. So let's do this whole thing on the part workbench. Normally I would use part design, and I would use a loft feature to define the blades. SolveSpace does not actually support lofting right now, so we're going to make the blades through another method, and that other method requires the part design functionality in FreeCAD, and that's to make something that would be truly comparable. Let's go to the sketcher, and I'll create a new sketch. Let's go in the XZ plane. Okay, let's start by drawing a profile of lines just like we did in SolveSpace here. And we can add some dimensions. Notice I've got my keyboard monitor up here. If you need to follow along with hotkeys, we're going to make that horizontal. We make that 1.59 millimeters. And we're going to go with horizontal here at 2 millimeters. We're going to make this horizontal at 6.35 millimeters. I'm going to go with making that vertical and horizontal. Give this a height of 152.4. We can give this a dimension of 5.4. Well, you know, we're fully defined. Back to the part workbench. Part part where we'll do a revolve. We want to revolve around the z-axis. And there's the revolution that we have in FreeCAD. Again, it's a little bit different if I were using the part design workbench, which I would normally use when making a part like this. Okay, let's go back to SolveSpace. You probably hear my beautiful and apparently very happy sounding daughter in the background, so sorry about that. Also, if we want to clean up our graphics area, we can always say hide all, and we're left with just the solid. And we can hide individual aspects of our design area by clicking these shown boxes. I'm going to leave everything shown for now, except I can probably hide the features on this lathe for a little bit of cleaning up. Let's add in a rectangle. Oh, but of course I need to have a plane to be sketching on. I like this plane. I'm going to hit Shift W to make that my work plane. Let's reference this point here and make it coincident. And coincident again there. And we're given an error. We know that this is an error because our background has changed and it says solve failed. It's actually a great way of dealing with errors. What I've done is I've made this coincident here and made this coincident here, and because both of these points are vertical when they're coincident, this vertical is now made redundant. So I can click on that and click delete, and we know that we solved the error because the background has changed. And hit Control Z, and I'm going to say you also can highlight over the conflicting constraints and choose the one that you don't like. And when you click on that, just hit the delete key and that will fix it also. Okay, so now that we look at our rectangle here, oops, let's Control Z that. So we're getting into our sketch. You can also hide certain aspects of how you're sketching so you can better see your sketch. I like this view, and I did that just by adjusting things, right? So this is what that looks like, and this is our very inside here. So let's merge these 2 points, and again we're given an error, and that's because we've merged this horizontal with this point. So we can simply choose this horizontal and hit the delete key, and now we should have 0 degrees of freedom, which we do. So this is our next fully defined sketch. We'll head on back to the home history tree, and I can hide some of these previous elements and show my body once more. I'll actually keep showing my elements though, because I like having that triad with the normals. With this, let's go ahead and make a blade profile. Again, lofting and sweeping is not really done in SolveSpace, so let's make these blades with another method. Alright, so let's add my helical feature now. I can choose my point and my normal just like I'm defining an axis. And I come up here and say new group and helix, and this produces a helical feature. You can see these thick white lines are going to show up as red on your screen. I made mine white because I think it's easier on the eyes. But there's a big error happening here, and that's because we have union selected. So we want to choose assemble. And now you can see we're taking this profile along a helical path, and the assemble helps us to assemble this, like combine the bodies. I'm going to choose the top line here and the top line of my ending profile, and I have an acute angle here, and that's important. I'm going to choose a degree angle, and the acute angle causes me to define it kind of how I would think about it, the angle like this. We make that a 70-degree angle. Our blade's a little bit short. Let's choose this line, which determines the height of my spiral, and add a dimension to make this 150 millimeters, and that will make us stop just shy of the top of our body here, right? So we have a 70-degree 150 height helical feature that we've just created. Let's do the same thing in FreeCAD, which I don't think there's a one-to-one in the way that I've defined this in FreeCAD, but we can do a little bit of math and figure it out. First thing, let's sketch on the same plane that we made our Revolve. So we'll head on back to Sketcher, create a sketch on the XZ plane. And these are going to come in as separate bodies, and I'm going to have, I can already tell I'm going to have a hard time fusing these. So for this video, I'm going to leave these unfused. I'm going to import this line, and we're going to merge these. Merge, just like that. And we're going to wireframe this. And let's see, our inner axis part was 25.4. So to avoid a possible zero thickness error, maybe if we have no zero thickness, it'll work. I don't know. Let's go with Shift H and maybe 26 millimeters, right? So it'll be not quite touching. I still think we'll have some problems, but maybe that'll help. So we'll close that. In fact, let's give this a try, right? Because we might be able to do this. Go through constraints. I believe it's constraint 3 that Alright, so here's our body. Let's start by sketching on the same plane that we revolved from. That will be, so we're in the sketcher, create a sketch on the XZ plane. I want to import this edge onto our sketch, so we'll grab our edge import tool here. And let's choose vertical. And I think this is going to come in, the blade is going to come in as a separate body from our Revolve. And I'm going to perhaps try in vain, to foresee any possible problems with fusing those together. Shift V for vertical, let's go with 0.01 millimeters, right? That's negligibly different in thickness, but it keeps the bottom of the blade from being kind of like a single point touching as we go to create the blade. So we're going to make this coincident. You can hear my very happy daughter. I'm going to Control H, and we're going to say 26 millimeters, so that we stop just short of the inside there. Now we want to add in a helical path to replicate the helix that we've created in SolveSpace. We're going to go with Part. We're going to add in this little feature here. Actually, no. We want to add in this from this button, plane, and we'll add in helix. We'll have, for now, our pitch be 150. Our height also at 150. Our radius will, let's have to figure out our radius, right? So we're going to create that for now, and that is our helix. Let's do some measuring because I don't recall what the radius is. So if you haven't seen this before, hopefully this helps somebody out. I'm going to choose my measure button and that point there, that point there. This is going to be 159.16 millimeters, and we know that that has a radius of ½ an inch. So we'll grab our calculator and we're going to say 159.16 plus 25.4 divided by 2, 171.86 would be our total radius of this thing. So I'll go back in our model, and looks like I've accidentally created 3 helixes, as I do sometimes. We're going to go with our radius, 150 here as well. Radius, what did I just have in my calculator? 171.86. There we have it. So in 1 revolution, we go that height. To clear up my view on the part design workbench, there we go. I got to close this, and I can purge my measurement view there, or toggle. Yeah, it's purge. So let's adjust our rotation to match 70 degrees. We want to say that we want our pitch to be our height, which is 150. Let's multiply that by a ratio of 360 divided by our desired length, or desired angle of 70 degrees. That's going to come out to 771.428, right? So we want our pitch to be 771.428. And that looks a lot like the sweep path of the profile that we have in SolveSpace, right? So it looks like we've done that right. Next, we can add in a part sweep. So we're going to sweep our sketch by our helix. Oh, actually, no, we don't want that. So we're going to move our helix back, and we're going to choose sweep path, and in the graphics display I can choose my helix. Done. Okay. And that does not quite look like the compressor blade that we want. So what we can do is we'll highlight our sweep, and under data, under Frenet, we'll say true. And then we'll rebuild, and that resweeps it to a blade that looks a lot more like what we have in SolveSpace. So out of curiosity, I've tried to avoid all possible zero thickness errors. If I take my my Revolve and my sweep, and I fuse them together, yep, we still get a fusion error. So I saw that coming, and it might be some kind of zero thickness related to this. I'm not sure. I'd have to look at it a lot more, but at least we're creating a model that looks like it's the same as SolveSpace. Let's head on back to SolveSpace and do a pattern. If I click on the home button, just so that we're viewing our history tree, this is what's active, right? So when I do something, it is on the active part. I want to do this button, which is for a polar pattern, and before I click it, I want to make sure that I have my normal selected. So there's my come on. There's my normal arrow, and there's my points. So I have my orientation and position defined. I'll choose polar pattern, and it defaults to 3. Nice looking compressor there. Let's go with, in our editor here, we have repeat 3 times. Let's make that 7 times, and enter. So we have a 7-bladed compressor, and that was easy enough. If we head on back to FreeCAD, we're going to go with our sweep here. Well, we highlight that, we go to draft, we'll choose an array, and then I like heading straight back to the part workbench. And in our array we can define a few things. Under data, instead of an ortho, we want a polar array. We'll change this to 1, and we'll change this to 1, and we'll change our top one. And if I can break this out a little bit, our number polar will be 7, I believe we went with. I'll hit the rebuild button, and there is our compressor in FreeCAD. So I have some trim in my final part. Let's head on back to SolveSpace and add some trim. I want to sketch on a plane, and let's go back home here. If I create a sketch just right now, right, it says can't draw in 3D, we must have an active work plane. The easiest way to do that is to click on a plane you want to sketch on, and it could be either one of these. And I'm going to say Shift W. Shift W activates the plane and gets me into Sketch. You can also define your own plane using, again, a line and a point, which, again, represents a normal, and the point is the position. So you select a point anywhere, and then a line anywhere. And just like how we define an axis, we define a plane the same way. Let's, in our sketch, create a circle. And this is just going to trim out the blades. You can make whatever profile you want or see fit. But when we add some trim on the blades, I'll do a circular profile. And I'm going to choose my planes as kind of a reference here. So we'll give this a dimension off the bottom of our compressor to be 239.64. We'll reference this plane with a dimension. We're going to make that 202.51, and then we're going to give this a diameter, and we're going to make the diameter 280.35. And we should have 0 degrees of freedom, which we do. We'll define an axis to sweep around, and I said sweep, I meant revolve. And of course I defined the wrong axis, right? I clicked the wrong thing. So let's actually hit the delete button. We're back to our fully constrained sketch. Where is a good normal? Maybe here at this point. Let's see if it likes that. Okay, we have this as union. We can choose assemble or intersection. And intersection, I think, is always the most interesting because that keeps the material where these two bodies intersect. But of course we want difference. So difference is like a subtractive revolve, right? And we'll go home. And just as we're fully parametric, I can change this to 9. That gives us an error for some reason. 8. We can change this. And actually, an 8-bladed compressor looks pretty sharp. Let's go with that. So there's our 8 blades. Let's go to FreeCAD and finish this up. Actually, you know what? That looks kind of busy. I'm going with 7. So there's our 7-bladed compressor. Let's go to FreeCAD and do the same thing. We'll go to the sketcher. Yeah, let's create a new sketch over here. Same plane. Create a circle. We'll add in the same dimensions. Shift V, 239.64. Shift H is going to be 202.51. We're going to actually make this a diameter, and 280.35. we'll do a revolved cut. Again, from the part workbench. And since we don't really have a cut function here, we're going to define a revolve around our Z on our latest sketch. And then I'll choose my array and my revolve in that order, and the order is important. And let's try to do a cut. There we go. So there is our cut, and I can use the space bar and hide my stuff. And that's a compressor. So quite different workflows and things to accomplish this. But in the end, I think we've got two excellent platforms that are both gifts for being open source. I hope this video was helpful. If it was, please subscribe, and I'll see you in the next one.